When dealing with a 480-volt system and the need for 120 volts power, several factors come into play when deciding whether to use a dedicated 120 volts transformer or to utilize the neutral, sometimes referred to as the Y node, of a 480 volts to 208 volts transformer. These considerations include safety, voltage regulation, fault current management, and equipment compatibility. Firstly, safety is paramount. A primary reason for using a 120 volts transformer is to ensure safer operating environment, particularly if the equipment being powered requires a low voltage for safe operation. Using a dedicated transformer isolates the 120 volt circuit from the higher voltage 480 volt system, reducing the risk of electrical shock. Secondly, voltage regulation is also an important factor. A 120 volts transformer can provide better voltage regulation than using the neutral point directly. This is especially true when the load is fluctuating. The transformer's design helps maintain a more stable voltage supply to the equipment, which can be critical for sensitive electronics and machinery. Thirdly, fault current limitation is another key benefit of using a 120 volts transformer. By introducing a transformer, you inherently limit the potential fault currents in the 120 volt circuit. This protection is crucial for safeguarding equipment and personnel from the dangers of high fault currents. Now let's consider the alternative using the neutral node of a 480 volts to 208 volts transformer to power 120 volts equipment. While technically feasible, this approach has limitations and potential risks. One major concern is voltage instability. The voltage at the neutral node can be more prone to fluctuations compared to the secondary voltage of a dedicated 120 volts transformer. This variability can lead to operational issues with the connected equipment. Additionally, unbalanced loads pose a problem. If the load connected to the neutral node is not evenly distributed across the phases, it can cause significant voltage regulation issues and potentially lead to overheating of the transformer. Safety is a heightened concern when using the neutral node for 120 volts equipment. The entire 480 volt system is still present on the primary side of the transformer, increasing the risk of electrical shock and other hazards. Proper grounding and overcurrent protection are essential, but the inherent risk remains higher than with a dedicated, isolated 120 volts transformer. Now let's discuss the common choice of 208 volt servos. The prevalence of 208 volt servos stems from their compatibility with the readily available 480 volts to 208 volts transformers. While 120 volt servos do exist, they may be less common and potentially more expensive, leading designers to opt for the 208 volts option. Ultimately, the decision to use a 120 volts transformer or to rely on the neutral node is a design choice. This choice must consider safety, voltage regulation requirements, fault protection measures, and the compatibility of the equipment being powered. Consulting with a qualified electrician or engineer is always recommended to determine the best and safest approach for a specific application. Remember that safety codes and local regulations might dictate specific requirements for voltage levels and transformer usage. Understanding these codes is crucial to ensure compliance and prevent potential hazards. From a practical standpoint, consider the following scenario. Suppose you have a servo panel that requires a stable 120 volt supply. Fluctuations in voltage can cause the servo motors to operate erratically, leading to inaccuracies or even damage. In this case, using a dedicated 120 volts transformer is likely the better option, as it provides a more stable and reliable voltage source. On the other hand, if you have a simple lighting circuit with minimal sensitivity to voltage fluctuations and a balanced load, using the neutral node might be acceptable, provided that all safety precautions are in place. Here are some additional points to consider. The kVA rating of the 480 volts to 208 volts transformer must be sufficient to handle the additional load of the 120 volt circuits if you are planning to use the neutral node. Overloading the transformer can lead to overheating and premature failure. Also ensure that the neutral conductor is properly sized to handle the expected current. An undersized neutral conductor can cause voltage drops and potentially create a fire hazard. Grounding is critical. Proper grounding of the transformer, the equipment, and the electrical panels is essential for safety and to minimize the risk of electrical shock. Follow all applicable electrical codes and standards when grounding the system. Overcurrent protection is equally important. Install appropriate fuses or circuit breakers to protect the circuits from overloads and short circuits. These devices should be sized according to the ampacity of the conductors and the requirements of the equipment being powered. Consider the long-term costs. While using the neutral node might seem like a cost-effective solution initially, the potential risks and limitations could lead to higher costs in the long run due to equipment damage, downtime, or safety incidents. A dedicated 120 volts transformer might have a higher upfront cost but could provide better reliability and safety, ultimately saving money in the long term. In conclusion, the decision to use a 120 volts transformer or the neutral node of a 480 volts to 208 volts transformer depends on a careful evaluation of various factors. There is no one-size-fits-all answer. Always prioritize safety, voltage regulation, and fault protection when making this decision. Consulting with experienced professionals and adhering to relevant electrical codes and standards is crucial for ensuring a safe and reliable electrical system.